This is K8BYP with the Drake TR-3 that's been about a 5-year project in the works and probably several $1,000s invested in this. The goal of this project was to take this venerable rig, go through it absolutely, completely, from both a design and manufacturing engineering perspective, learn everything that could be known about it, document it, because this knowledge is disappearing quickly, and to be able to completely remanufacture this radio, including solving all the legacy problems like low power on the bottom of 80 meters and VFO drift. All that's been identified and eliminated. Here's the front page of the article from 2018 January CQ magazine where this radio is featured. That's a part now to do some final work on the VFO mechanism. There's the VFO with the can cover removed. And down inside we can see that the threaded shaft, which that's the original, gets very worn. So anticipating that someday that'll be damaged beyond repair, it's been replaced with precision screw and nut from an industrial source. The VFO mechanism inside has been completely redesigned. The coil assembly is an ferrite original. The final amplifier cage was completely disassembled, air variables removed, clean, fins straightened, reassembled, new grounding for the shafts. Bad grounds in this capacitor opened up and caused severe arcing back in the plate circuit. The original relay was arcing due to age, couldn't polish it, so it was replaced with the modern ice cube relay. New parasitic suppressor networks. The arcing here caused the destruction of this choke, plate choke, so it was rewound with the same served copper wire as original. Underneath there has been very extensive work. Firstly, to replace all the old thin insulated high voltage wire for the 650, 250, and 150 volt sources. There was about half a dozen wires in this area in the transmitter that were arcing to the chassis. To ensure correct operation, the final tube sockets were replaced with new ceramic sockets, all the capacitors replaced, the layout improved, lead shortened, high voltage choke rerouted. There's a grid resistor here that's been replaced with a 2-watt because they can fail under just wrong condition and destroy the final tubes. Here's the replacement TR relay. It's a Potter and Brumfield 4PDT, similar to what's in the TR-4. This and the TR-4 I've redone are different because this only switches the receive. The transmit output goes straight to the antenna jack. That eliminates any chance of that relay failing and opening the output of the transmitter. The new sideband filter in 2 parts, here and here, is made with brand new state-of-the-art high-end crystals directly from a manufacturer in Taiwan. They have 6 to 9 ohms resistance, which is essentially 0. There's a single filter instead of 2, and to accommodate upper and lower sidebands there are 2 carrier crystals that are both adjustable, so the carrier offset can be adjusted to whatever we want, and to accommodate the fact that the sideband filter skirt shapes are different top and bottom. A major improvement was adding an RIT. Here's the RIT board. It was a real trick to get that built into this high impedance VFO, to put it in without initially throwing the VFO way off frequency. And here's a potentiometer and switch that does both RIT and push-pull for sideband select. Back here is a relay switching board that accomplishes some TR switching, presents low impedance outputs to the key and a microphone push to talk so they can't bring RFI in, and a high-speed carrier mute relay to mute spurious carrier from leakage coming out of the balance modulator. There's a very serious problem with these old brown daughter boards, as I call them, that are riveted. They, in some cases, they put the rivets in too tightly, it cracked the board. Cracks cause later current leakage and arcing. And on the TR-4, the corner of this board was literally burned. So I had to go through and fix all those. All new electrolytics, all new high voltage ceramic capacitors. All the tubes have been taken out. Their pins sanded shiny like they were new. The envelopes cleaned. And all new, better alignment procedures found with state-of-the-art modern test equipment. Back together and in its operating position, you see the about 13 CFM cooling fan over top of the 3 final tubes. They really need some cooling. When they get too hot, they make creaking noises. We'll turn this on and see the startup delay and the 12-volt DC switching power supply. There's no 60 cycle whatsoever in this radio. It's all been eliminated, including the off-on switches, which is now a remote 9 to 12 volt sensing switch, which flips a relay back in the power supply so the 60 cycle AC line doesn't go through the radio. So there's a warm-up delay of about 8 seconds. And most of the VFO drift has been eliminated. See the filaments, 12-volt filament string just flipped up to full power. The cooling fan is tied to the PA tube filaments, which is also switchable and also from a 17-volt switch mode supply, which allows this radio to use any voltage or any combination of voltage of JB6 tubes, 6, 12, or 17, in 3s or mix and match. The RIT control is here. Which is extremely useful in AM mode working in a group, because it's rare that, especially with old transmitters, that they're all on the same frequency. So since this has a beat detector for AM, if the received signal is off frequency, there'll be a tone like this. So instead of jogging the VFO knob back and forth, which also changes the transmit frequency, use the RIT to tune in the AM signals. In CW, the process is to set the RIT at 0 beat on a station calling CQ, then shift the frequency a little bit, and that sets the CW offset to any signal, any frequency I want, instead of being fixed at about 900 to 1000, which is awfully high. That is very useful to be able to get away from a interfering CW signal. It can tune then the CW note to either sideband. If that's 0 and that's one sideband, it can be tuned to the other, which is weaker, but it might get away from another signal up or down the band. I'll go through a tune-up. This is a tube radio, and misadjustment of the plate and load controls will damage the final tubes. The AC-857 acts as a memory keyer through a conversion circuit I designed and put in this box to take the side tone output from any ham rig and strip off the tone and regenerate the original keying signal. So when I tap on the paddle, you see the TR-3 finals go to idle, and the idle is set at 100 milliamps. Don't set that too low, or there'll be severe distortion from the transmitter. Set it too high, the plates will start glowing red. So it's important to get it just right. The TR and relay modifications have been set so that the rig can also be keyed from the mic push to talk instead of having to plug a key in and do the key and then close a shorting bar for phone. That's really annoying. And in the next video, we'll fire it up and have a high-speed CW contactor QSO on a 60-year-old rig. K8BYP out.